By the end of our journey, you might not have all the answers, for some mysteries are meant to be cherished rather than solved, but you will certainly have a deeper appreciation for the profound secrets hiding in the stars, and perhaps a new, more mindful way of looking at the world around you. So take a deep breath, let it out slowly, feel your body relax, and let's begin our mindful exploration of the cosmos, one gentle moment at a time. This introduction is designed to set a tone of calm and wonder, preparing you for a journey that is as much about inner reflection as it is about outer space. It emphasizes the human connection to the stars, both ancient and modern, and invites a relaxed, contemplative approach to learning. The aim is to create an atmosphere where complex scientific ideas can be absorbed peacefully, fostering a sense of awe and connection to the universe. This gentle beginning will lay the groundwork for the deeper, more intricate mysteries we are about to uncover, ensuring that the listener feels grounded and at ease throughout the entire experience. The journey will be long, but it will be a journey of discovery, peace, and profound connection to the cosmic tapestry that surrounds us all. Let the whispers of the universe guide you gently towards rest and understanding. Ancient mysteries and the myths that preceded science. As we continue our gentle journey through the cosmic tapestry, let us now drift back in time, far beyond the age of telescopes and space probes, to a period when the night sky was not just a spectacle, but a sacred text, a living canvas upon which humanity projected its deepest fears, its grandest hopes, and its most profound questions. For millennia, before the advent of scientific inquiry as we know it, ancient cultures around the world looked up at the same stars we see today, and in their twinkling lights, they saw not just distant suns, but secrets, stories, and prophecies. These were the myths that preceded science, rich narratives that sought to explain the inexplicable, to bring order to the chaos of the cosmos, and to connect the human experience to the vast, mysterious forces at play above. How did ancient cultures see secrets in the sky? They saw them in the predictable cycles of the sun and moon, which dictated the rhythms of their lives, from planting and harvesting to religious festivals. They saw them in the unchanging patterns of the constellations, which served as celestial maps, guiding their travels and marking the passage of time. But more than just practical tools, the stars were imbued with spiritual significance. They were the homes of gods and goddesses, the battlegrounds of celestial beings, the harbingers of fate. The rising and setting of certain stars, the appearance of comets, or the rare spectacle of an eclipse were not random events. They were messages, omens, secrets whispered from the heavens, demanding interpretation. Priests, shamans, and astronomers, often one and the same, dedicated their lives to deciphering these celestial communications, believing that understanding the sky was key to understanding their world and their destiny. These interpretations formed the bedrock of their cosmologies, their understanding of the universe and their place within it. The secrets were not hidden from them, but hidden in the patterns, waiting for human consciousness to give them meaning. This was a time when the boundary between the sacred and the scientific was blurred, where observation and belief intertwined to create a rich tapestry of understanding. Consider some of the most iconic celestial objects and the myths woven around them. The Pleiades, that shimmering cluster of seven sisters, visible to the naked eye, held a special place in countless cultures. In Greek mythology, they were the daughters of Atlas, pursued by Orion, eventually transformed into stars. For the Maori of New Zealand, they were Matariki, marking the beginning of the new year. In Japan, they are Subaru, giving their name to a car constellation. Across the globe, these stars were associated with agriculture, navigation, and the passage of time, their appearance signaling crucial moments in the annual cycle. Orion's belt, 3 bright stars in a row, was another universal marker. To the ancient Egyptians, Orion was associated with Osiris, the god of the afterlife, and the constellation played a role in their beliefs about resurrection. For many indigenous cultures, it represented a hunter, a warrior, or a powerful animal. These constellations were not just random groupings of stars, they were characters in epic cosmic dramas, their movements across the night sky telling stories that reinforced cultural values and explained the natural world. And then there is the Milky Way, that luminous band of light stretching across the night sky, our own galaxy seen from within. For many ancient peoples, it was a river, a pathway for souls to the afterlife, a celestial road. The Incas saw it as the celestial river that flowed through the heavens, mirroring the earthly rivers that sustained their lives. In some African traditions, it was the smoke from a giant fire, or the spilled milk of a goddess. These myths, while diverse, share a common thread. They sought to explain the grandeur and mystery of the Milky Way, to integrate it into their worldview, and to find meaning in its ethereal glow. The secrets of the Milky Way were not just about its composition, but about its spiritual significance, its connection to life, death, and the journey of the soul. These stories, passed down through generations, were not just entertainment, they were explanations, guides, and profound expressions of humanity's relationship with the cosmos. What is truly remarkable is how many ancient civilizations, without the aid of modern technology, managed to make incredibly accurate cosmic calculations. The megalithic structures of Stonehenge, the pyramids of Egypt, the observatories of the Maya. These were not just architectural marvels, but sophisticated astronomical instruments. They tracked the movements of the sun, moon, and stars with astonishing precision, predicting solstices, equinoxes, and even eclipses. These ancient astronomers, through generations of meticulous observation, uncovered secrets of celestial mechanics that allowed them to create calendars, organize their societies, and plan their agricultural cycles. The secrets they left behind were not just myths, but tangible evidence of their deep understanding of the cosmos, a knowledge gained through patient observation and careful record-keeping. They understood the predictable rhythms of the heavens, and they built their lives around them, demonstrating a profound connection between earthly existence and celestial movements. Their accuracy often astonishes modern scientists, highlighting a different kind of scientific method, one rooted in long-term patient observation and the accumulation of empirical data over centuries. This brings us to a gentle reflection. Where does the border lie between magical and scientific in these star stories? For ancient peoples, there was often no such clear distinction. The universe was alive, imbued with spirit and meaning, and the movements of the stars were part of that living tapestry. Their explanations, while not based on our modern understanding of physics, served a vital purpose. They provided coherence, meaning, and a sense of control in a world that could often feel unpredictable and overwhelming. The myths were their science, their way of making sense of the cosmos. As science evolved, we began to seek explanations based on observable phenomena, testable hypotheses, and mathematical laws. We replaced the stories of gods with the laws of gravity, the omens of comets with their orbital mechanics. But in doing so, have we lost something? Have we perhaps traded a sense of wonder and connection for a purely mechanistic understanding? This is not to say that one is better than the other, but rather to acknowledge that both approaches, the mythical and the scientific, are deeply human ways of engaging with the mysteries of the universe. The secrets of the stars, whether seen through the lens of ancient myth or modern science, continue to inspire awe, to challenge our understanding, and to remind us of the profound beauty and complexity of the cosmos. The myths remind us that the stars are not just objects of scientific study, but also sources of inspiration, wonder, and profound human meaning. They are a testament to our innate desire to find meaning and narrative in the vastness of the universe, to connect the human story with the cosmic story. This ancient wisdom, though different in its methodology, shares with modern science the fundamental human drive to understand the secrets hiding in the stars, to unravel the mysteries of the cosmos, and to find our place within its grand design. And as we move forward, we carry with us the echoes of these ancient stories, recognizing that the human quest for understanding the stars is a continuous, evolving narrative, always building upon the foundations laid by those who gazed up before us. Invisible forces, the hidden architecture of the sky. Having explored the ancient myths and human stories woven into the fabric of the night sky, let us now gently shift our gaze from the visible patterns to the invisible forces that truly sculpt the cosmos. Imagine, if you will, a grand silent architect, working tirelessly behind the scenes, shaping galaxies, bending light, and holding stars in their orbits. This architect is not a mythical being, but a fundamental force of nature, often unseen, yet profoundly powerful. We're talking, of course, about gravity and its more mysterious cosmic cousins, dark matter and dark energy. These invisible forces form the hidden architecture of the sky, dictating the grand ballet of the universe, from the smallest asteroid to the largest supercluster of galaxies. Gravity, the silent sculptor of the cosmos, is perhaps the most familiar of these forces, yet its true nature remains a profound mystery. We experience its pull every moment of our lives, keeping our feet firmly on the ground, making apples fall from trees, and holding our planet in orbit around the sun. But gravity's influence extends far beyond our immediate experience. It's the force that pulled together the primordial gas and dust after the Big Bang, forming the first stars and galaxies. It is the force that keeps billions of stars bound together in majestic spiral arms, and it is the force that draws galaxies into vast cosmic webs, creating the large-scale structure of the universe. Einstein's theory of general relativity revolutionized our understanding of gravity, describing it not as a force pulling objects together, but as a curvature of space-time itself. Imagine a bowling ball placed on a stretched rubber sheet. It creates a dip. If you then roll a marble near the bowling ball, the marble will curve towards the dip, not because the bowling ball is pulling it, but because the sheet itself is curved. Similarly, massive objects like stars and planets warp the fabric of space-time around them, and what we perceive as gravity is simply objects following the curves in this warped space-time. This elegant and profound understanding reveals gravity as the ultimate cosmic choreographer, silently shaping everything we see and much of what we don't. But here's where the mystery deepens and where our understanding of the universe takes a truly bizarre turn. Dark matter and dark energy. For decades, astronomers observed that galaxies were spinning too fast and galaxy clusters were holding together too tightly for the amount of visible matter they contained. It was as if there was extra unseen mass providing the gravitational glue. This led to the hypothesis of dark matter, a mysterious substance that doesn't emit, absorb, or reflect light, making it utterly invisible to our telescopes. We can't see it, we can't touch it, and we can't directly detect it, but we know it's there because of its gravitational effects. It's estimated that dark matter makes up about 27% of the universe's mass, dwarfing the ordinary matter, stars, planets, us, that makes up only about 5%. Imagine trying to understand a building when 90% of its structure is invisible. Dark matter is the scaffolding upon which the visible universe is built, a silent, unseen partner in the cosmic dance of gravity. Its nature remains one of the biggest unsolved puzzles in physics, a secret so profound that it challenges our very understanding of what matter is. And then there's dark energy, an even more enigmatic force. In the late 1990s, observations of distant supernovae revealed a shocking truth. The expansion of the universe is not slowing down due to gravity, as was previously thought, but is actually accelerating. This acceleration requires a mysterious repulsive force, something that pushes space-time apart. This force was dubbed dark energy, and it's even more dominant than dark matter, making up an astonishing 68% of the universe's total energy density. While dark matter acts like an invisible gravitational glue, dark energy acts like an invisible anti-gravity, pushing everything apart. Its nature is even more mysterious than dark matter. It's not a particle or a substance, but seems to be an intrinsic property of space itself, a kind of cosmic pressure that is driving the universe towards an ever faster expansion. The existence of dark matter and dark energy means that the vast majority of our universe is made of stuff we cannot see, cannot touch, and do not understand. They are the ultimate invisible architects, shaping the destiny of the cosmos in ways we are only just beginning to comprehend. One of the most compelling pieces of evidence for these invisible forces, particularly dark matter, comes from a phenomenon called gravitational lensing. Remember how Einstein's theory says that massive objects curve spacetime. This curvature doesn't just affect the paths of planets and stars, it also bends the path of light. Just as a glass lens can focus or distort light, a massive galaxy or cluster of galaxies can act as a cosmic lens, bending the light from even more distant objects behind them. When astronomers observe these distant galaxies through a massive foreground cluster, they'd often see distorted, stretched, or even multiple images of the background galaxies. The amount of distortion tells us how much mass is in the foreground cluster. And here's the crucial part. The amount of mass required to produce the observed lensing effect is far greater than the mass of the visible stars and gas in the cluster. This discrepancy is strong evidence for the presence of vast amounts of invisible dark matter, providing the extra gravitational pull needed to bend light to such an extent. Gravitational lensing is like seeing the invisible wind by observing how it rustles the leaves. We can't see dark matter directly, but we can see its profound effect on the light from distant parts of the universe, revealing its hidden presence and its role in shaping the cosmic landscape. So, what does this mean for our understanding of the universe? It means that the universe we see, the stars, the galaxies, the nebulae, the planets, everything that twinkles and shines, is just a small fraction of what's truly out there. The vast majority of the cosmos is composed of these invisible, mysterious components that we are only just beginning to probe. It's a humbling thought, reminding us of the limits of our perception and the immense secrets that still lie hidden in plain sight. It's like living in a house where you can only see the furniture, but not the walls, the foundation, or the roof. The furniture is important, but it's the unseen structure that truly defines the building. Similarly, dark matter and dark energy are the unseen foundation and framework of the universe, dictating its evolution and its ultimate fate. Their existence challenges us to expand our minds, to think beyond the visible and to embrace the profound mysteries that still surround us. Let's take a moment for a mindful reflection on these unseen forces. Close your eyes gently or soften your gaze and imagine the world around you. You see the chair you're sitting on, the walls of your room, the light from a lamp. But beneath the surface, unseen forces are constantly at work. Gravity holds you to the earth. The electromagnetic force holds the atoms of your body together, and the atoms of the chair. The strong and weak nuclear forces bind the very nuclei of those atoms. Now, extend that thought to the cosmos. Imagine the vast, empty spaces between galaxies. They might seem empty, but they are filled with the invisible presence of dark matter, gently pulling and dark energy subtly pushing. What unseen things shape your own world? Perhaps it's the silent force of habit, the invisible threads of connection to loved ones, the subtle influence of past experiences, or the unseen currents of future aspirations. Just as the universe is shaped by forces we cannot see, our own lives are often guided by invisible influences, emotions, beliefs, memories, and dreams that are just as real and powerful as anything we can touch or see. This reflection encourages us to look beyond the obvious, to appreciate the hidden depths and complexities of both the cosmos and our own inner worlds. It's a reminder that true understanding often comes from acknowledging what we don't yet know and from being open to the profound mysteries that lie just beyond the veil of our perception. This quiet contemplation of the unseen helps us to appreciate the subtle, yet powerful, influences that shape our reality, both cosmic and personal. It's a beautiful testament to the hidden architecture that underpins all of existence, inviting us to wonder about the deeper layers of reality that are always present, even if they remain invisible to our direct senses. Oddball stars and impossible phenomena. Having journeyed through the invisible forces that sculpt the cosmos, let us now turn our attention to the stars themselves, not just as distant points of light, but as incredible, often bizarre cosmic entities. If you thought our own sun was interesting, prepare to have your mind gently expanded, for the universe is home to stars that defy imagination, stars that spin faster than anything you can conceive, stars that are made of the densest material known, and stars that briefly return from the dead. These are the oddball stars and the seemingly impossible phenomena that challenge our understanding and reveal the true wild diversity of the cosmos. Our sun is a relatively ordinary star, a stable, middle-aged yellow dwarf. But out there in the vast cosmic ocean are stars that are anything but ordinary. Imagine a star so dense that a teaspoon of its material would weigh billions of tons, more than all the cars on Earth combined. These are neutron stars, the collapsed cores of massive stars that exploded as supernova. When a star much larger than our sun runs out of fuel, its core collapses under its own immense gravity, crushing protons and electrons together to form neutrons. The result is an incredibly compact object, typically only about 12 miles, 20 kilometers across, yet containing more mass than our entire sun. They are the universe's ultimate cosmic compactors, taking something vast and turning it into something impossibly small and dense. Their gravity is so intense that if you were to stand on one, you would be instantly flattened into a thin layer of atoms. They are the cosmic equivalent of a diamond, but infinitely harder and denser. Some neutron stars are even stranger. They are pulsars. These are rapidly spinning neutron stars that emit beams of radiation from their magnetic poles. As the star spins, these beams sweep across space, much like the beam from a lighthouse. If one of these beams happens to sweep across Earth, we detect it as a regular pulse of radio waves, hence the name pulsar. Some pulsars spin hundreds, even thousands of times per second, making them the fastest spinning objects in the universe. Imagine a city-sized object rotating faster than a blender. This incredible rotation is a remnant of the original star's collapse. As it shrinks, it spins faster, conserving its angular momentum. The precision of these pulses is astonishing, more accurate than atomic clocks, making them invaluable tools for astronomers studying the fabric of space-time. They are like cosmic metronomes, ticking away with incredible regularity, a testament to the extreme physics at play. Even more extreme are magnetars, a rare type of neutron star with incredibly powerful magnetic fields, quadrillions of times stronger than Earth's magnetic field. These fields are so intense that they can warp space-time, tear apart atoms, and even affect the very structure of matter. When a magnetar experiences the starquake, a sudden rearrangement of its crust, it can release an enormous burst of X-rays and gamma rays, so powerful that it can affect Earth's atmosphere from thousands of light years away. These are the universe's ultimate magnetic monsters, silent, invisible, yet capable of unleashing unimaginable power, a true testament to the bizarre extremes that gravity and electromagnetism can create. And then there are white dwarfs, the gentle, cooling embers of stars like our sun. When our sun eventually runs out of fuel, it will shed its outer layers, leaving behind a dense, hot core about the size of Earth. This is a white dwarf. They are incredibly dense, though not as dense as neutron stars. A teaspoon of white dwarf material would still weigh several tons. White dwarfs slowly cool over billions of years, eventually becoming cold, dark black dwarfs, though no black dwarfs are thought to exist yet, as the universe isn't old enough for them to have fully cooled. They are the universe's cosmic cooling coals, slowly fading into the darkness, a quiet end to a long and luminous life. But some white dwarfs have a more dramatic fate. Imagine a zombie star that briefly returns from death. These are Type E supernova, and they are truly spectacular. This happens when a white dwarf star is part of a binary system, orbiting another star. If the white dwarf is close enough, its immense gravity can pull material, mostly hydrogen and helium, from its companion star. As this material accumulates on the white dwarf's surface, it eventually reaches a critical mass, a point where the pressure and temperature becomes so immense that a runaway nuclear fusion reaction ignites across its entire surface. The white dwarf explodes in a brilliant cataclysmic flash, briefly outshining an entire galaxy. This explosion completely destroys the white dwarf, leaving nothing behind. These type of supernovae are incredibly important to astronomers because they all explode with roughly the same intrinsic brightness, making them standard candles that can be used to measure vast cosmic distances and even track the expansion of the universe. They are a cosmic fireworks display, a final glorious act of the star that briefly defied its own death, a true zombie star. The universe also hosts weird variable stars and unexplainable star-dimming events. Some stars, known as variable stars, change their brightness over time, sometimes in predictable cycles, sometimes erratically. These variations can be due to internal processes, like pulsations, or external factors, like orbiting companions. But then there are truly puzzling cases, like Tabby's star KOIC 8,462,852, which we will discuss more in a later section. This star exhibited bizarre, irregular dimming events, sometimes by as much as 22%, that could not be easily explained by conventional astronomical phenomena, like orbiting planets or dust clouds. The dimming was so strange and asymmetric that it led to wild speculation, including the possibility of alien megastructures orbiting the star. While most scientists now lean towards natural explanations involving dust, the mystery of Tabby's star highlights how much we still don't know about the diverse and often inexplicable behaviors of stars. Thought break. If stars can be so odd, what normal things around us hide strangeness? Take a moment to reflect on the everyday objects and phenomena in your own life. The chair you're sitting on, the air you breathe, the water you drink. Do you ever stop to think about the incredible complexity hidden within them? The atoms that make up your hand are mostly empty space, yet they feel solid. The air around you is a swirling dance of countless molecules, yet it seems still. The water in your glass, seemingly simple, hides a universe of quantum interactions and chemical bonds. Even the most mundane things, when viewed through a scientific lens, reveal layers of astonishing complexity and strangeness. The fact that we can walk through walls if our atoms were perfectly aligned, or that a single drop of water contains more molecules than there are stars in the observable universe, are everyday miracles that we often take for granted. This reflection encourages us to cultivate a sense of wonder not just for the distant cosmos, but for the immediate world around us, recognizing that the extraordinary is often hidden within the ordinary, waiting for us to notice. Just as the stars hold secrets, so too does the seemingly familiar world we inhabit, inviting us to look closer, to question, and to marvel at the hidden strangeness that underpins our reality. This pause reminds us that the universe's wonders are not confined to distant galaxies, but are present in every atom, every interaction, every moment of our lives, if only we choose to see them. It's a gentle invitation to bring the cosmic wonder down to earth, to find the extraordinary in the ordinary, and to appreciate the profound strangeness that permeates all of existence. The secrets hidden in starlight. We have journeyed through the ancient myths, explored the invisible forces that sculpt the cosmos, and marveled at the bizarre lives of oddball stars. Now, let us turn our attention to something seemingly simple, yet profoundly revealing: starlight itself. That gentle twinkle you see in the night sky is not just a pretty sight. It is a cosmic messenger carrying secrets from billions of miles away, telling us tales of distant worlds, the chemistry of stars, and even whispers from the very edge of the universe. Just as a detective can piece together a story from subtle clues, astronomers can read the secrets hidden in starlight, unlocking the mysteries of the cosmos. One of the most powerful tools in an astronomer's arsenal is spectroscopy, the art and science of reading a star's chemistry and age for its light. Imagine taking the light from a distant star and passing it through a prism, just like a rainbow. Instead of a continuous band of colors, you would see a spectrum with dark lines, or sometimes bright lines, at very specific wavelengths. These lines are like cosmic fingerprints. Every chemical element, when heated, emits or absorbs light at its own unique set of wavelengths. By analyzing these spectral lines, astronomers can determine what elements a star is made of, whether it's rich in hydrogen, helium, iron, or other heavier elements. This tells us about the star's composition, its temperature, its density, and even its age. For example, older stars tend to have fewer heavy elements because these elements are forged in the hearts of stars and dispersed into space only when those stars die. So a star with very few heavy elements is likely a very old star, born early in the universe's history. Spectroscopy is like having a universal translator for starlight, allowing us to understand the fundamental building blocks of the cosmos and the processes that shape them. It's a silent conversation across unimaginable distances, where light itself becomes the language. Beyond composition, starlight also reveals the presence of distant worlds through exoplanet transits. For centuries, humanity could only dream of planets beyond our solar system. Now, thanks to clever techniques, we have discovered thousands of them. One of the most successful methods involves observing the subtle dimming of a star's light as a planet passes directly in front of it from our perspective. Imagine a tiny fly crossing in front of a powerful distant lamp. The light from the lamp would momentarily dim ever so slightly. Similarly, when an exoplanet transits its host star, it blocks a tiny fraction of the star's light, causing a measurable dip in its brightness. By carefully monitoring these dips, astronomers can deduce the size of the planet, its orbital period, and even, in some cases, get clues about its atmosphere. The duration of the transit tells us about the planet's orbital speed, and the frequency of the dips tells us how long a year is on that distant world. This method has revolutionized our search for habitable planets, allowing us to identify worlds that might have the right conditions for liquid water and potentially life. Each tiny dip in starlight is a whisper from a distant world, a secret revealed about a planet we can never hope to visit in person, yet can learn so much about through its subtle influence on its star's light. And then there are the truly enigmatic secrets hidden in starlight, the cosmic radio mysteries like the famous WOW signal. In 1977, while scanning the skies for radio signals, a volunteer astronomer at Ohio State University's Big Ear radio telescope detected an incredibly strong, narrowband radio signal that lasted for 72 seconds. It was so strong and so unusual that the astronomer Jerry Inman circled the corresponding alphanumeric printout and wrote WOW next to it. The signal came from the direction of the constellation Sagittarius, but it never repeated. Despite numerous attempts to redetect it, the WOW signal remains a one-off and unexplained anomaly. Was it a natural phenomenon we don't understand? Or was it, as many hoped, a genuine message from an intelligent extraterrestrial civilization? The mystery persists, a tantalizing hint that we might not be alone in the vast cosmic ocean. The WOW signal is a powerful reminder that starlight and the broader electromagnetic spectrum can carry messages we don't yet fully comprehend, signals that challenge our assumptions and ignite our imagination. Beyond the WOW signal, there are other cosmic radio mysteries that continue to puzzle astronomers. Fast radio bursts, FRBs, for example, are incredibly powerful, millisecond-long bursts of radio waves that originate from distant galaxies. While many FRBs have now been detected, and some have even been traced to specific galaxies, Their exact origin and the mechanisms that produce them remain largely unknown. Some FRBs repeat, while others are one-offs adding to the enigma. Are they caused by exotic astrophysical phenomena like magnetars, or something even stranger? These fleeting signals, traveling across billions of light years, carry secrets about extreme cosmic events, pushing the boundaries of our understanding of the universe's most energetic processes. Each burst is a cosmic riddle, a fleeting message from the depths of space, waiting for us to decipher its meaning. Gentle reflection, the messages we send, and myths through our own starlight. Just as starlight carries information across vast distances, our own lives are filled with subtle signals, with unspoken messages with the quiet starlight we emit through our actions, our words, our presence. How often do we truly listen to the subtle cues from those around us? How often do we pay attention to the unspoken messages in a glance, a gesture, a moment of silence? In our fast-paced world, we are often so focused on the loud, the obvious, the immediate, that we miss the gentle, profound starlight that surrounds us. Perhaps it's the quiet support of a friend, the unspoken love of a family member, the subtle beauty of a sunrise, or the profound wisdom in a moment of stillness. These are the signals that often go unnoticed, yet they carry immense meaning and connection. This reflection encourages us to cultivate a deeper sense of awareness, to tune into the subtle frequencies of life, to become better interpreters of the starlight in our own world. Just as astronomers patiently decode the light from distant stars, we too can learn to patiently decode the subtle messages that enrich our lives, fostering deeper connections and a greater appreciation for the hidden beauty and meaning that surrounds us. It's a reminder that the universe's secrets are not just out there, but also within us and in the quiet, gentle interactions that define our human experience. This mindful pause invites us to bring the cosmic lesson of observation and interpretation back to our personal lives, enriching our understanding of both the universe and ourselves. It's a beautiful testament to the interconnectedness of all things, from the grandest cosmic signals to the most intimate human exchanges, all carrying their own unique and profound secrets. Black holes, dark hearts, and extremes. We have journeyed through the visible and invisible wonders of the cosmos, from ancient myths to the secrets hidden in starlight. Now, let us venture into the most enigmatic and extreme objects in the universe, black holes. These cosmic behemoths are not just theoretical constructs, they are real, powerful, and profoundly mysterious entities that challenge our understanding of space, time, and gravity. They are the dark hearts of the cosmos, places where the laws of physics as we know them break down, and where the very fabric of reality is stretched to its limits. So, what exactly makes a black hole, and why are they invisible? A black hole is formed when a massive star, much larger than our sun, exhausts its nuclear fuel and collapses under its own immense gravity. Unlike a neutron star, which resists collapse due to neutron degeneracy pressure, a black hole's gravity is so overwhelming that nothing, not even light, can escape its pull. This is why they are black and invisible. We cannot see them directly because they do not emit or reflect any light. Instead, we detect their presence by observing their gravitational effects on nearby stars and gas, or by the powerful S-rays emitted by superheated materials spiraling into them. Imagine a cosmic drain pulling everything towards it with an irresistible force. The boundary around a black hole, beyond which nothing can escape, is called the event horizon. This is not a physical surface, but a point of no return, a boundary in space-time. Once something crosses the event horizon, it is irrevocably lost to the black hole, forever removed from our observable universe. It's a one-way trip into the unknown, a cosmic threshold that marks the ultimate limit of escape. What happens if you were to fall into a black hole? This is where the concepts of spaghettification and time dilation come into play, painting a truly bizarre and terrifying picture. As you approach a black hole, the gravitational pull on your feet, closer to the black hole, would be significantly stronger than the pull on your head further away. This difference in gravitational force would stretch your body out like a piece of spaghetti, a process aptly named spaghettification. You would be stretched thinner and thinner, longer and longer, until your body was reduced to a stream of individual atoms. It's a gruesome, yet fascinating, consequence of extreme gravity. But even stranger is the phenomenon of time dilation. As you get closer to the event horizon, time for you would appear to slow down relative to an observer far away from the black hole. If someone were watching you fall in, they would see you moving slower and slower, eventually appearing to freeze at the event horizon, never quite crossing it from their perspective. For you, however, time would continue normally, and you would cross the event horizon in a finite amount of your own time, eventually reaching the singularity, the infinitely dense point at the very center of the black hole where all the mass is concentrated, and where our current laws of physics completely break down. This extreme warping of space-time near a black hole is a profound testament to Einstein's theory of general relativity, revealing a universe far more flexible and strange than our everyday experience suggests. While stellar mass black holes are formed from the collapse of individual massive stars, there's another, even more monstrous type, supermassive black holes. These are the giants of the cosmos, with masses ranging from millions to billions of times that of our Sun. They reside at the centers of almost all large galaxies, including our own Milky Way, which harbors Sagittarius A asterisk, pronounced Sagittarius A star at its core. These supermassive black holes are not just passive gravitational anchors. They play a crucial role in the evolution of galaxies. Their immense gravity influences the orbits of stars and gas clouds throughout the galaxy, and in some cases they can actively feed on surrounding matter, becoming incredibly luminous quasars that outshine entire galaxies. The exact mechanism of their formation is still a subject of intense research, but they are believed to grow by accreting gas and dust, and by merging with other black holes during galactic collisions. They are the silent, powerful engines that drive galactic evolution, shaping the destinies of billions of stars and countless worlds. The year 2019 marked a historic moment in astronomy when the Event Horizon Telescope, EHT, collaboration released the first ever image of a black hole's shadow. This wasn't an image of the black hole itself, since it's invisible, but rather of the superheated gas swirling around the event horizon of the supermassive black hole at the center of the galaxy, Messier 87 M87. The image showed a bright ring of emission surrounding a dark central region, the black hole's shadow. This groundbreaking achievement provided direct visual evidence of a black hole and its event horizon, confirming predictions made by Einstein's theory of general relativity over a century ago. It was a monumental triumph of international collaboration and technological ingenuity, allowing humanity to see the unseeable for the first time. The image revealed not just the presence of the black hole, but also the extreme conditions of the plasma orbiting it, providing invaluable data for testing our theories of gravity in the most extreme environments. It was a powerful reminder that even the most abstract and bizarre predictions of physics can, with enough ingenuity, be observed and confirmed, pushing the boundaries of human knowledge and inspiring awe at the universe's profound mysteries. Story pause. Imagining a journey into a black hole. Close your eyes gently or soften your gaze. Imagine yourself floating in the vast, silent darkness of space, approaching a black hole. You see the swirling fiery disk of superheated gas and dust, glowing with unimaginable intensity, like a cosmic whirlpool. As you get closer, the light from distant stars behind the black hole begins to distort, bending and stretching around its invisible boundary, creating strange, shimmering arcs and rings. You feel a gentle, yet inexorable, pull drawing you closer to the event horizon. Time begins to stretch, moments feeling like eternities. You pass the point of no return, the event horizon, and the universe outside seems to shrink, its light fading into a tiny, distant point. You are now truly alone, falling deeper into the dark heart of space-time, towards the singularity. The forces begin to stretch you, pulling you apart atom by atom, until you become one with the fabric of the black hole itself. There is no light, no sound, only the profound silence of ultimate gravity. This is not a journey you would survive, but it is a journey that pushes the limits of our imagination, forcing us to confront the most extreme and mysterious aspects of our universe. This thought experiment, while terrifying, helps us to grasp the truly alien nature of black holes, places where our familiar notions of space and time cease to exist, and where the universe reveals its most profound and terrifying secrets. It's a journey into the heart of darkness, a place where the laws of physics are rewritten, and where the ultimate secrets of gravity might reside. This imaginative exercise serves to deepen our appreciation for the extreme physics that govern these cosmic monsters, and the profound implications they hold for our understanding of the universe. It's a reminder that the cosmos is full of wonders that defy our everyday experience, inviting us to expand our minds and embrace the truly bizarre. The secrets of black holes are not just about their immense gravity, but about the very nature of reality itself, waiting to be unraveled by the persistent curiosity of humanity. Ghosts and remnants, supernova, neutrinos, and cosmic rays. We have journeyed into the heart of darkness with black holes, and now let us turn our attention to the universe's most spectacular and violent events, the death of stars and the ghostly particles they leave behind. These are the supernova, the neutrinos, and the cosmic rays, remnants and echoes of cosmic violence that, paradoxically, are essential for the existence of life itself. They are the universe's way of recycling, of transforming the old into the new, and of scattering the ingredients for future stars, planets, and even ourselves across the vast cosmic canvas. The violence and rebirth of supernova explosions are among the most awe-inspiring phenomena in the cosmos. A supernova is the catastrophic explosion of a star, marking the dramatic end of its life. There are different types of supernova, but the most common and spectacular are those that occur when a massive star, many times larger than our Sun, runs out of nuclear fuel. For billions of years, these stars fuse lighter elements into heavier ones in their cores, creating elements like carbon, oxygen, and even iron. But once the core becomes iron, it can no longer produce energy through fusion. Without the outward pressure from fusion, the core collapses in a fraction of a second, triggering a massive shockwave that blasts the star's outer layers into space at incredible speeds. This explosion is so powerful that for a brief period, a single supernova can outshine an entire galaxy, radiating as much energy as the Sun will produce in its entire 10 billion year lifetime. The remnants of these explosions are vast, expanding clouds of gas and dust, enriched with all the heavy elements forged in the star's core and during the explosion itself. These elements, the carbon in our bodies, the oxygen we breathe, the iron in our blood, and the gold in our jewelry, were all created in the fiery hearts of stars and scattered across the universe by supernova. We are, quite literally, stardust, the children of these cosmic explosions. Supernova are not just events of destruction. They are also acts of cosmic creation, seeding the universe with the building blocks of complexity and life. Then there are neutrinos, billions passing through each second and almost never stopping. These are perhaps the most elusive and ghostly particles in the universe. Neutrinos are fundamental particles, incredibly tiny with almost no mass, and they interact very, very weakly with other matter. They are produced in vast quantities by nuclear reactions, such as those occurring in the core of our Sun, in supernova, and even in nuclear reactors on Earth. Every second, trillions of neutrinos from the Sun pass through your body, through the Earth, and through everything around you without you ever noticing. They are like cosmic phantoms, silently traversing the universe, rarely leaving a trace. Detecting them requires massive, highly sensitive detectors, often buried deep underground to shield them from other particles. The fact that they pass through matter so easily makes them incredibly valuable messengers from the most extreme environments in the universe, providing a unique window into processes that are otherwise hidden from our view. For example, when a supernova explodes, a burst of neutrinos is released even before the light from the explosion reaches us, providing an early warning system for these cosmic catastrophes. The study of neutrinos is a frontier of physics, revealing secrets about the fundamental nature of matter and the universe's most energetic events. And finally, cosmic rays, high-energy visitors from distant, unknown events. These are not rays in the traditional sense, but rather extremely energetic particles, mostly protons and atomic nuclei that travel through space at nearly the speed of light. They originate from violent cosmic events, such as supernova, active galactic nuclei, the supermassive black holes at the centers of galaxies, and other extreme astrophysical phenomena. When these cosmic rays strike Earth's atmosphere, they collide with atoms, creating a shower of secondary particles that can reach the ground. While most cosmic rays are harmless, the most energetic ones carry energies far beyond anything we can produce in our most powerful particle accelerators on Earth. Their exact sources and the mechanisms that accelerate them to such incredible energies remain one of the enduring mysteries in astrophysics. They are like cosmic bullets, fired from the most extreme corners of the universe, carrying information about processes we are only just beginning to understand. The study of cosmic rays provides clues about the most powerful accelerators in the universe and the conditions in distant galaxies, offering a glimpse into the raw, untamed energy of the cosmos. The paradox of cosmic violence creating the ingredients for life is a profound and beautiful concept. It's a testament to the universe's incredible ability to transform destruction into creation. The varied elements that make up our bodies, the carbon, oxygen, nitrogen, and all the other heavier elements, were not present in the early universe. The Big Bang primarily produced hydrogen and helium. All the other elements were forged in the hearts of stars through nuclear fusion, and then scattered across the cosmos by the violent explosions of supernova. Without these stellar deaths, without this cosmic violence, the universe would be a much simpler, less interesting place, devoid of the complex chemistry necessary for planets, for life, and for us. So, the next time you look at your hand, remember that you are holding a piece of a star, a remnant of a cosmic explosion that happened billions of years ago. It's a powerful reminder that life, in its most fundamental sense, is a product of the universe's grand, violent, and beautiful cycle of creation and destruction. This paradox highlights the interconnectedness of all things in the cosmos, demonstrating how even the most destructive events can lead to the most profound and beautiful outcomes. It's a story of cosmic recycling, where the death of one generation of stars provides the raw materials for the birth of the next, and ultimately for the emergence of life itself. This profound understanding brings a sense of deep connection to the universe, reminding us that we are not separate from the cosmos, but an integral part of its ongoing dynamic evolution. The secrets of these cosmic ghosts and remnants are not just about their physical properties, but about the very origins of our existence, a silent testament to the universe's incredible capacity for transformation and renewal. This section aims to convey the awe-inspiring nature of these cosmic phenomena and their direct relevance to our existence, fostering a sense of wonder and connection to the vast, dynamic universe. It emphasizes the cyclical nature of cosmic processes, where destruction paves the way for creation, and how these seemingly violent events are fundamental to the emergence of life and complexity. This narrative approach helps to make complex scientific concepts accessible and emotionally resonant, inviting the listener to feel a deeper connection to the cosmic story. The strange life and death of planets. We have journeyed through the fiery lives and violent deaths of stars, and the ghostly remnants they leave behind. Now, let us turn our gaze to the worlds that orbit these stars, the planets. Our own Earth, with its vibrant life and delicate balance, might seem like the norm, but the universe is filled with planets far stranger and more extreme than anything we can easily imagine. From worlds that wander aimlessly through the cosmos to planets made of diamonds, the strange life and death of planets reveal yet another layer of the universe's profound and often bizarre secrets. Imagine a world without a sun, a planet adrift in the cold, dark interstellar void. These are rogue planets, also known as free-floating planets or orphan planets. Unlike Earth, which is gravitationally bound to our sun, rogue planets have been ejected from their parent star systems, or perhaps never even formed within one. They wander through the galaxy, alone and unlit, illuminated only by the faint glow of distant stars or the occasional brief encounter with another celestial body. How we find them if they don't emit light? Astronomers detect them through a phenomenon called microlensing, where the rogue planet's gravity temporarily magnifies the light from a more distant star as it passes in front of it. While seemingly desolate, some theories suggest that if these rogue planets are large enough and had a thick enough atmosphere, they could potentially retain internal heat from their formation, or from radioactive decay, possibly even harboring subsurface oceans of liquid water and perhaps life. The existence of rogue planets challenges our traditional view of planetary systems, revealing a universe where worlds can exist independently of stars, a testament to the vast and varied possibilities of cosmic existence. They are the silent wanderers of the cosmos, carrying their secrets through the endless night. Beyond the wanderers, the universe is home to planets with truly fantastical compositions and conditions. Imagine a diamond planet, a world where the very ground beneath your feet is made of pure, crystalline carbon. Such planets are theorized to exist around stars that are rich in carbon, where the building blocks of the planet would be predominantly carbon, rather than silicon and oxygen like Earth. Under immense pressure and heat, this carbon could crystallize into diamond, creating entire worlds of glittering precious stone. Then there are molten glass planets, worlds so hot that their atmospheres contain vaporized rock, which then condenses into tiny glass particles that rain down onto the surface. Imagine a constant, searing downpour of molten glass, and perhaps even stranger worlds with raining iron, where the temperatures are so extreme that iron vaporizes in the atmosphere, only to condense and fall as liquid iron rain. These are not just theoretical musings. Astronomers are finding evidence of such extreme exoplanets, pushing the boundaries of what we thought possible for planetary formation and evolution. These discoveries remind us that our own Earth, with its temperate climate and abundant water, is a very special and perhaps rare oasis in a universe filled with truly alien and hostile environments. Our own Earth, seemingly so stable and secure, has had its own share of near misses with cosmic impacts and stellar bursts, reminding us of the fragility of life in a wild universe. The history of our planet is punctuated by catastrophic events, from asteroid impacts that wiped out the dinosaurs to massive volcanic eruptions that reshaped continents. While these events are rare on human timescales, they are a constant threat in the vastness of cosmic time. Our planet is constantly bombarded by small meteoroids, most of which burn up harmlessly in the atmosphere. But larger objects like asteroids and comets pose a significant threat capable of causing widespread devastation. Scientists constantly monitor near-Earth objects, tracking their trajectories to predict potential impacts. Beyond impacts our Sun, while generally stable, can also unleash powerful solar flares and coronal mass ejections, bursts of radiation and charged particles that can disrupt satellites, power grids, and even pose a threat to astronauts in space. And in the distant past, Earth would have been exposed to more intense radiation from nearby supernovae, which could have triggered mass extinctions. These cosmic events, while terrifying, are a natural part of the universe's dynamic processes. and they serve as a powerful reminder of the delicate balance that allows life to flourish on Earth. Our planet is not an isolated sanctuary, but a small, vulnerable ship sailing through a vast and sometimes dangerous cosmic ocean. Gentle pause on the fragility of life in a wild universe. Close your eyes gently or soften your gaze. Imagine the vastness of space, the countless stars, the swirling galaxies, the immense distances. Now, picture our tiny blue planet, a vibrant speck of life, suspended in that immense cosmic ocean. Feel the delicate balance that allows life to thrive here, the perfect distance from the sun, the protective atmosphere, the presence of liquid water, the stable magnetic field. Consider how easily this balance could be disrupted by a rogue asteroid, a powerful solar flare, or a nearby supernova. This reflection is not meant to instill fear, but to cultivate a profound sense of appreciation for the preciousness and resilience of life on Earth. It reminds us that our existence is a cosmic miracle, a rare and beautiful outcome in a universe that is often harsh and unforgiving. It encourages us to cherish the delicate web of life that surrounds us, to protect our planet, and to live with a deeper awareness of our interconnectedness with the cosmos. Just as a single flower can bloom in the harshest desert, life finds a way to flourish even in the most challenging cosmic environments. This mindful pause invites us to embrace the wonder and fragility of our existence, fostering a sense of gratitude for the unique conditions that allow us to be here, gazing up at the very stars that forge the elements within us. It's a beautiful testament to the resilience of life and the profound, often precarious, conditions that allow it to flourish in the wild, untamed universe. This section aims to highlight the incredible diversity of planets beyond our solar system and the extreme conditions that can exist on them, while also bringing the focus back to the fragility and preciousness of life on Earth. It encourages a sense of wonder and appreciation for our unique planetary home within the vastness of the cosmos. The narrative weaves together scientific discoveries with moments of reflection, making complex ideas accessible and emotionally resonant. Unsolved mysteries and astronomical anomalies. We have journeyed through the known and the extreme, from the invisible forces that shape galaxies to the bizarre lives of stars and the strange existence of planets. Now, let us venture into the truly unknown, the fringes of our cosmic understanding, where science grapples with phenomena that defy easy explanation. These are the unsolved mysteries and astronomical anomalies, the cosmic riddles that keep astronomers awake at night, pushing the boundaries of our knowledge and reminding us just how much more there is to discover in the vast, enigmatic universe. They are the universe's way of whispering, "You haven't figured me out yet." One of the most captivating and persistent enigmas in recent astronomy is the phenomenon of fast radio bursts, FRBs. Imagine, if you will, a powerful flash of radio waves, lasting for mere milliseconds, originating from billions of light years away. These are FVRBs, and they are incredibly energetic, releasing as much energy in a thousandth of a second as the sun does in a day. The first FRB was discovered in 2007, and since then, hundreds more have been detected. While some FRBs are one-off events, never to be seen again, a fascinating subset of them are repeaters, sending out multiple bursts from the same location in the sky. This repetition provides a crucial clue, suggesting that the source is not a cataclysmic, destructive event, like a supernova, but rather something that can survive and continue to emit. The exact origin of FRBs remains one of the hottest topics in astrophysics. Are they caused by highly magnetized neutron stars, magnetars, undergoing starquakes? Are they signals from exotic, unknown astrophysical phenomena? Or, as some have wildly speculated, could they be signs of advanced extraterrestrial civilizations? While the latter is highly unlikely and not supported by current evidence, the sheer mystery and power of FRBs continue to fuel our imagination. Each new detection brings us closer to understanding these cosmic flashes, But for now, they remain a profound puzzle, a cosmic beacon from an unknown source, challenging our understanding of extreme physics in the universe. Another intriguing anomaly that has captured the attention of astronomers and the public alike is Tabby's star, officially known as KIC 8,000,000. 462,852. This ordinary-looking F-type star, located about 1,470 light-years away, gained notoriety in 2015 when astronomers noticed its bizarre and unprecedented dimming patterns. Unlike the regular, predictable dips in brightness caused by transiting planets, Tabby's star exhibited irregular, non-periodic dimming events, sometimes by as much as 22%, lasting for days or even weeks. The dimming was so strange and asymmetric that it couldn't be easily explained by conventional astronomical phenomena like orbiting planets, dust clouds, or stellar activity. The sheer scale and irregularity of the dimming led to wild speculation, including the highly publicized, yet scientifically unsupported, hypothesis of an alien megastructure, such as a Dyson sphere, being built around the star, while subsequent research has largely pointed towards natural explanations, such as a swarm of comets or a large irregular cloud of dust orbiting the star. The exact cause of Tabby's star's unusual behavior remains a subject of ongoing debate and research. It serves as a powerful reminder that the universe is full of unexpected phenomena, and that our current models and theories may not always be sufficient to explain everything we observe. Tabby's star is a cosmic enigma, a silent challenge to our assumptions, and a testament to the universe's endless capacity for surprise. Beyond these specific observations, there are fundamental puzzles that challenge our very understanding of the universe's composition and evolution. One such puzzle is the missing antimatter problem. According to our best theories, the Big Bang should have produced equal amounts of matter and antimatter. When matter and antimatter meet, they annihilate each other in a flash of energy. If this were the case, the early universe should have been a sea of radiation, with no matter left over to form stars, galaxies, and this. Yet here we are in a universe overwhelmingly dominated by matter. Where did all the antimatter go? Why is there this profound matter/energy asymmetry? This is one of the biggest unsolved problems in cosmology. Some theories propose that there was a tiny, almost imperceptible imbalance in the early universe, a slight excess of matter over antimatter, which, over billions of years, led to the matter-dominated universe we see today. Other theories suggest that antimatter might exist in distant, unobservable regions of the universe, or that there are fundamental differences in how matter and antimatter interact that we don't yet understand. The missing antimatter problem is a profound cosmological riddle, hinting at fundamental physics beyond our current grasp, and reminding us that the universe's very existence is built upon a delicate, unexplained imbalance. Then there's the mysterious Great Attractor, a region pulling whole galaxies unseen. For decades, astronomers have observed that our Milky Way galaxy, along with thousands of other galaxies in our local supercluster, are all being pulled towards a mysterious, massive region of space. This region, located about 250 million light-years away in the direction of the Centaurus constellation, is known as the Great Attractor. It's not a single object, but a vast, diffuse concentration of mass, so immense that its gravitational pull is affecting the motion of galaxies across a significant portion of the observable universe. The challenge is that much of the Great Attractor lies behind the zone of avoidance, a region of the sky obscured by the dust and gas of our own Milky Way galaxy, making it difficult to observe directly. While astronomers have identified some large galaxy clusters and superclusters within this region, their combined mass still doesn't fully account for the observed gravitational pull. This suggests that a significant portion of the Great Attractor's mass is likely composed of dark matter, further emphasizing the pervasive and mysterious influence of this invisible substance. The Great Attractor is a cosmic gravitational anomaly, a silent, unseen hand guiding the movements of entire galaxies, a testament to the universe's hidden structures and the profound influence of gravity on the largest scales. These are just a few examples of the many unsolved mysteries and astronomical anomalies that populate the cosmos. From the perplexing nature of dark matter and dark energy, which constitute the vast majority of the universe, to the enigmatic fast radio bursts and the strange dimming of Tabby's star, the universe continues to present us with profound questions that challenge our current understanding. These anomalies are not failures of science, rather they are powerful drivers of discovery, pushing scientists to develop new theories, build more powerful instruments, and explore new frontiers of knowledge. They are the universe's way of inviting us to look deeper, to question our assumptions, and to embrace the unknown. Reflection. The beauty of living with unanswered questions. In our human tendency, we often seek definitive answers, clear explanations, and a sense of certainty. We want to solve the puzzle, to complete the picture, to fill in all the blanks. But the universe, in its infinite wisdom, often resists such neat categorization. The unsolved mysteries of the cosmos are not a sign of our limitations, but a testament to the boundless nature of reality itself. There is a profound beauty in living with unanswered questions, in embracing the unknown, in allowing for the possibility that our current understanding is incomplete. It fosters humility, encourages curiosity, and keeps the flame of wonder alive. Just as a beautiful piece of music can be appreciated for its unresolved chords, or a captivating story for its lingering ambiguities, the universe's mysteries invite us to a deeper, more contemplative engagement. They remind us that the journey of discovery is often more rewarding than the destination, and that the process of asking questions is as important as finding answers. This reflection encourages us to find peace and joy in the vastness of what we don't yet know, to cultivate a sense of awe for the universe's enduring enigmas, and to recognize that true wisdom often lies in the acceptance of mystery. It's a gentle invitation to let go of the need for absolute certainty, and to simply revel in the profound, beautiful, and endlessly fascinating secrets that the cosmos continues to hold, forever inviting us to wonder, to explore, and to dream. This section aims to highlight the cutting edge of astronomical research, showcasing phenomena that currently defy full explanation. It emphasizes that these anomalies are not scientific failures, but rather opportunities for new discoveries and deeper understanding. The reflection encourages a positive outlook on the unknown, fostering a sense of wonder and humility in the face of cosmic mysteries. It reinforces the theme of the write-up, that the universe is full of secrets, and that the journey of discovery is ongoing and endlessly fascinating. The edge of knowing, multiverse, simulation, and philosophical secrets. We have journeyed deep into the known and the unknown, from the visible wonders of the night sky to the invisible forces that sculpt galaxies, from the bizarre lives of stars to the profound mysteries of black holes and the anomalies that challenge our understanding. Now, as we approach the very edge of our current scientific and philosophical knowing, let us gently step into the realm of the truly speculative, where the lines between science fiction and theoretical physics blur, and where the universe reveals secrets that might redefine our very understanding of reality. These are the concepts of the multiverse, the simulation hypothesis, and the deepest philosophical questions about the nature of existence itself. Are there infinite universes? This is a question that has moved from the realm of pure philosophy into serious scientific consideration. The concept of a multiverse suggests that our universe is not the only one, but rather one of many, perhaps an infinite number of universes. There are several theoretical frameworks that lead to the idea of a multiverse. One comes from inflationary cosmology, a theory that describes the rapid expansion of the universe immediately after the Big Bang. If inflation is eternal, meaning it never truly stops everywhere, then new universes could be constantly bubbling off from our own, each with potentially different physical laws, different fundamental constants, and different initial conditions. Imagine an infinite cosmic foam with each bubble representing a separate universe. Another idea comes from quantum mechanics, specifically the many worlds interpretation, which suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different possible outcome. In this view, every decision you make, every path you don't take, actually happens in a different universe. What would one even look like? If these other universes exist, they could be incredibly similar to ours, differing only in a single quantum event, or they could be wildly different, with different dimensions, different forces, and different forms of matter. The implications are staggering. If there are infinite universes, then every possible scenario, no matter how improbable, would eventually play out somewhere. This concept challenges our sense of uniqueness and expands our understanding of reality to an almost incomprehensible scale. While currently untestable, the multiverse hypothesis offers a tantalizing solution to some of the universe's deepest puzzles, such as why our universe seems so perfectly fine-tuned for life. Perhaps we simply exist in one of the universes where the conditions are just right. Even more mind-bending is the question: is our universe a computer simulation? Why do some physicists and philosophers seriously consider it? This idea, often called the simulation hypothesis, proposes that our entire reality, including our consciousness, is an elaborate computer simulation created by a more advanced civilization. The argument often goes like this: if a civilization reaches a certain level of technological maturity, they would likely develop the ability to create highly realistic simulations of their ancestors or of past societies. If they can do this, and if they run many such simulations, then the statistical probability suggests that we are more likely to be living in one of those simulations than in the original base reality. Think of it like this: if you have one real world and a million simulated worlds, the odds are 1,000,000 to 1 that you're in a simulation. This hypothesis is not just a philosophical thought experiment. Some physicists have even proposed potential ways to test it, looking for glitches in the fabric of reality or for computational limits that might manifest as subtle anomalies in physical laws. While highly controversial and lacking definitive evidence, the simulation hypothesis forces us to question the very nature of reality, consciousness, and existence. It challenges our intuitive understanding of what is real and what is not, inviting us to consider that our perceived reality might be just one layer in a much larger, more complex computational hierarchy. It's a profound secret. If true, that would redefine everything we thought we knew about the universe. And then there's the question of where the universe ends, if it ends at all. Our observable universe, the part we can see, is a vast sphere about 93 billion light-years in diameter. But this is just the part from which light has had time to reach us since the Big Bang. What lies beyond? Does the universe simply continue indefinitely, an infinite expanse of galaxies and cosmic structures? Or does it have an edge, a boundary beyond which there is nothing, or something entirely different? Current cosmological models, particularly those based on the idea of an infinite flat universe, suggest that the universe is indeed infinite and has no edge. If you were to travel in a straight line, you would never reach a boundary. However, other models, such as those that propose a finite, curved universe like the surface of a sphere, but in higher dimensions, suggest that while it might not have an edge, it could still be finite in size. In such a universe, if you traveled far enough in a straight line, you would eventually return to your starting point, much like sailing around the Earth. The question of the universe's ultimate size and shape remains one of the most fundamental and unanswered questions in cosmology. It's a secret that lies beyond our current observational capabilities, pushing the limits of our imagination and our scientific instruments. The universe's boundary, or lack thereof, is a profound philosophical secret, hinting at the true scale and nature of existence, a mystery that continues to inspire awe and wonder. Poetic meditation on cosmic humility and human imagination. Close your eyes gently or soften your gaze. Imagine the vastness of these ideas. Infinite universes, the simulated reality, a universe without end. Feel the profound sense of humility that comes with contemplating such grand concepts. We, as tiny beings on a small planet, are attempting to grasp the entirety of existence. Yet simultaneously feel the immense power of your own imagination, your capacity to conceive of such ideas, to ask such questions, to reach beyond the limits of your immediate experience. It is this unique human capacity for wonder, for curiosity, for abstract thought that allows us to even begin to touch upon these cosmic secrets. Our imagination is a bridge between the known and the unknown, a tool that allows us to explore possibilities that lie beyond our current grasp. This meditation encourages us to embrace both our smallness in the face of the cosmos and our immense capacity for understanding and wonder. It's a reminder that the greatest secrets of the universe are not just out there, but also within us in the boundless depths of our own minds. This reflection aims to connect the abstract concepts of the multiverse and simulation theory to the human experience, fostering a sense of awe and humility while celebrating the power of human imagination. It encourages listeners to embrace the unknown and find beauty in the unanswered questions, reinforcing the overall theme of mindful exploration of cosmic mysteries. This section serves as a bridge between the scientific and the philosophical, inviting a deeper, more personal engagement with the profound secrets of existence. It emphasizes that the journey of discovery is as much about inner reflection as it is about outer exploration, reminding us that the universe's greatest mysteries often reside at the intersection of the two. Sleepy Science Stories for the Night Sky. We have journeyed through the grand tapestry of cosmic secrets, from the visible wonders to the invisible forces, from the bizarre lives of stars to the philosophical edges of knowing. Now, as our exploration gently winds down, let us settle into a more narrative, almost dreamlike space. These are sleepy science stories designed to lull your mind into a state of peaceful contemplation, allowing the vastness and beauty of the universe to wash over you, guiding you gently towards rest. These stories are not just about facts, they are about feeling, about connection, and about finding a sense of calm in the cosmic dance. Let us begin with a gentle narrative, following a photon from a star to your eye. Imagine, if you will, a tiny, massless particle of light, a photon, born in the fiery heart of a distant star billions of years ago. This star, perhaps a red giant, was nearing the end of its life, its core churning with nuclear fusion, releasing immense energy. Our little photon, a mere flicker of light, began its incredible journey. It first had to fight its way out of the star's dense interior, a journey that could take thousands of years, bouncing from atom to atom, slowly making its way to the surface. Once free, it launched itself into the vast, empty expanse of space, traveling at the fastest speed possible in the universe, the speed of light. For millions, perhaps billions of years, it traveled, crossing unimaginable distances, passing countless galaxies, nebulae and other stars, a silent, tireless messenger. It might have dodged a black hole's gravitational pull, surfed the waves of dark energy, or simply sailed through the cosmic void. Its path was straight, unwavering, a testament to the emptiness of space. And then, one quiet night after a journey spanning eons and light years, it finally arrived. It entered Earth's atmosphere, perhaps briefly scattering off a dust particle, before gently, softly landing on the retina of your eye. In that infinitesimal fraction of a second, that single photon delivered its ancient message, a whisper from a distant star, a secret from the dawn of time. It was a journey of incredible duration and distance, all for that one moment of connection, that one spark of light that allowed you to see a star. This story reminds us of the profound interconnectedness of everything and the incredible journeys that light undertakes to bring the universe to our very eyes, a silent, timeless bridge between the cosmic and the personal. Now, let's imagine if the stars could speak. What would they tell us? They would speak of age, of unimaginable stretches of time. The oldest stars would whisper tales of the early universe, of the first galaxies forming, of the cosmic dark ages before light filled the cosmos. They would speak of the birth of elements of hydrogen and helium fusing into carbon, oxygen, and iron, the very building blocks of life. They would speak of the slow, majestic dance of galaxies, of collisions and mergers that reshape cosmic landscapes over billions of years. They would speak of distance, of the vast, empty stretches between them, and the loneliness of existing for eons in silence. They would speak of cosmic kinship, of being part of a grand, interconnected web where the death of one star fuels the birth of another, and where the elements forged in their hearts eventually become planets and even living beings. They would speak of patience, of the slow, deliberate processes that shape the universe, reminding us that true change often takes time, immense amounts of time. They would speak of their own fiery lives, their struggles against gravity, their luminous triumphs, and their eventual quiet demises. They would speak of the profound beauty of the cosmos, of nebulae painted with cosmic dust, of galaxies spiraling in elegant dances, of the silent, breathtaking ballad of creation and destruction. And perhaps they would speak of us, tiny, fleeting beings on a small blue planet, gazing up at them, wondering, dreaming, and trying to understand their ancient secrets. Their voices would be the hum of cosmic background radiation, the whisper of solar winds, the silent flash of supernova, and the gentle twinkle of their distant light. They would tell us that we are not separate from the universe, but an integral part of its ongoing story, made of the same stardust, connected by the same cosmic threads. Their message would be one of profound peace, of interconnectedness, and of the enduring mystery that binds us all. Finally, let us contemplate the story of the end of our sun and how our solar system's future is written in the stars. Our sun, that comforting, life-giving star, is currently about halfway through its 10 billion year lifespan. It is a stable, middle-aged yellow dwarf, providing the perfect conditions for life on Earth. But like all stars, it too will eventually run out of fuel. In about 5 billion years, our sun will begin to change. It will swell into a red giant, expanding so much that it will likely engulf Mercury and Venus, and possibly even Earth. The oceans will boil away, the atmosphere will be stripped, and our planet, if it survives, will become a scorched, lifeless cinder. This will be a slow, majestic, and inevitable transformation, a cosmic sunset that will last for millions of years. After its red giant phase, the sun will shed its outer layers, forming a beautiful planetary nebula, a colorful, expanding shell of gas and dust. At the center of this nebula, the sun's core will remain, a dense, hot white dwarf, slowly cooling over trillions of years, eventually becoming a cold, dark black dwarf. This is the quiet, dignified end of our star, a cosmic echo of its once brilliant life. This future, though billions of years away, is already written in the laws of physics, in the life cycle of stars, and in the very elements that make up our solar system. It's a reminder that everything, even stars, has a beginning, a middle, and an end. But in this ending, there is also a profound sense of continuity. The elements that our sun sheds into space will eventually become part of new nebulae, new stars, and new planets, continuing the cosmic cycle of creation and destruction. Our solar system's future is not just about its demise, but about its transformation, its contribution to the ongoing story of the universe. It's a gentle reminder that even in endings, there is a promise of new beginnings, a cosmic dance of transformation that ensures the universe continues to evolve, to create, and to reveal its endless secrets. This story, while contemplating an end, is meant to bring a sense of peace and acceptance, recognition of the natural cycles of the cosmos, and our place within them. It's a cosmic lullaby, inviting you to rest in the knowledge that you are part of something vast, ancient, and endlessly unfolding. This section aims to provide comforting, narrative-driven scientific explanations, allowing the listener to absorb complex ideas in a relaxed state. It uses vivid imagery and gentle pacing to create a sense of wonder and connection to the cosmos, reinforcing the theme of the universe's profound secrets and our place within them. The stories are designed to be both informative and soothing, guiding the listener towards a peaceful and contemplative state.